Okay, moving on to 11.2, we're talking about linear equations in two variables. So just looking at the wording here, we're going to be dealing with equations. We're going to have two variables in the equation, and the equation is called linear. And all that means is that we're going to see two variables in here. They're going to be x and they're going to be y. And that we are going to see x and y to the first power. We're not going to see any x squareds or y squareds or anything like that. And that's what makes this linear. So as long as we have two variables, we have an equation and our variables are both raised to the first power, we are going to be dealing with a linear equation in two variables. So that's what it says here. Linear equation, two variables. An equation contains two different variables, both raised to the first power, and neither of the variables can be in a denominator or something like that. Okay, so we can't have any fractions. So the standard form of a linear equation looks like this. So a here is just a number in front of x, and then b is just another number in front of x, and the other side of the equation is just some number. So let's just take a look at the following and see if they're linear or not. So this first one is not linear because we have an x in the denominator, so that is not linear. Okay, this one, we have a number in front of x, so we have like an a in front of x. We have a b in front of y. We have an equal sign. We have another number, that would be c. So it looks like this. Don't worry about the -4. It's okay to have a minus there. So this is a linear equation. This one is, and this one is not because the y is squared. So now, that's just recognition of what's a linear equation in two variables and not. So the whole idea here is that if you're given, let's say you go back and you look at an equation like this, x plus 4 equals 8. That's a linear equation in one variable because we only have one letter here. And we could solve this by subtracting 4 on both sides, and we could get x equals 4. And that would be our solution. But here, because we have two variables, we are going to have multiple solutions, and I'll show you that as we move on. But there's a big difference between a linear equation in one variable and a linear equation in two variables. So let's just move into this example and see if this makes sense. Determine if the given ordered pair is a solution to this equation. So remember, with an ordered pair, this is x and this is y. So what they're really asking us to do here is to take this equation, linear equation in two variables, and replace x with 3 and replace y with 2 and see if it's true. So we're going to see, is it still true or not? So I'm going to write this down. I'm going to do -5, and I'm going to replace x with 3, so times 3, plus 3, and then replace y with 2 times 2. Does that equal -9? That's the question. So let's figure out what the left side is. Okay, we do multiplication before we do addition, so we're going to do -5 times 3, that's -15. And then plus 3 times 2 is 6. And the question is, does that equal 9? Well, if we take -15 and we add 6, we get -9. And that means that is not true. Oh wait, oh, sorry, it is, I forgot to put -9 there. Negative, yes, so it is true. It is true. I accidentally forgot to bring my negative. So yes, that is, this ordered pair is a solution to that linear equation. Okay, let's try this one. Okay, so I'm going to replace x with -12. I'm going to replace y with, I'm going to replace y with 2. And I'm going to see what happens. So let me replace the y with 2. Does that equal 2/3 times -12, replacing x with -12 plus 6? So this is the question, is this true? So does 2 equal, now I need to do 2/3 times -12. I'm going to write -12 as a fraction, and then I'm going to multiply straight across. I get -24/3, but that's just -8. So these together become -8, and then plus 6. And -8 plus 6 is -2, and they are not equal. So is this a solution? No. So not every ordered pair is a solution to a linear equation, only certain ones. So our goal is going to be to determine whether or not, what ordered pairs work and what don't. So for the given linear equation, here it is, we are going to check to see right now which of these 1, 2, 3, 4 ordered pairs are solutions. So let me try this first one. Remember, I'm replacing the x with 2 and the y with 3. So let's write that down. It'll be 2 plus 3. Does that equal 5? Question mark. Yes, it does. So this is a solution. Let's try the next one. Negative 2 plus, let's see, y has to be 7. Does that equal 5? Well, negative 2 plus 7 is 5, so 5 equals 5. That's true, yes. So that is a solution. How about this one? 4 plus y is 1. Does that equal 5? Yes, that's true. So that is a solution. How about this one? 8 plus negative 3. Does that equal 5? 8 take away 3, that's 5. Yes, that works. So all of these are solutions to that linear equation that was given. And since they're solutions, the first time we've done this, we're actually going to go now and plot these solutions just like we did in the previous exercises. So let me do 2, 3 first. I go to the right 2, go up 3, I put a dot. Next one, negative 2, 7. So I go to left 2, up 7, puts me here. The next one is 4, 1. So I go right 4, up 1. And the last one is 8, negative 3. So I go to the right 8, down 1, 2, 3. There we go. There are solutions. Now, do we notice anything about these points? Well, I think you see that these points all, oh my goodness, whoa. This computer's weird. Okay, all these points lie on a straight line. And that is where the name linear equation comes from. The fact that when you plot all the solutions to the equation, you actually form a line, which means that if you were to pick any other point that was on that line, it should also work. Let me re-illustrate what I mean here. Let me draw a better line. So let me try this. This thing's real touchy here. It's not doing a very good job for me. There we go, that's better. See if I can... There it goes. Okay. So there's the line that goes through those points. Let's try and find another point that we can tell where it is. I think y'all can tell that this point lies on the line. And that point looks like the point 6, negative 1. So I went to the right 6 and down 1. Does that work into that original linear equation, 2 variables? Let's try it. 6 plus negative 1. That gives me 5. That checks. That's true. So any point that lies on this line should be a solution to that original linear equation. So we actually have an infinite number of answers. Okay, so what do we notice about the points? They lie on a line. Okay, the points on a line represent the solutions to the equation of the line, and they're an infinite number of solutions then. Compare that to that problem we did way in the beginning here when I said, what if we have one equation, or one variable? Then there's only usually one solution. But what we're learning here is that with these linear equations in 2 variables, we actually have an infinite number of solutions. So one way we can graph lines is by constructing what's called a t-table. All right, so I'm going to show you how this works. If somebody gives you a linear equation, what you can do is just start plugging values in. Just you pick them, whatever values you want, just pick them for x and y. So right now, if I pick the value 2 for x, then the question is, what do I get for y? So let's take the equation x plus y equals 3. Let's just replace the x with 2, and that's what we get. Now we have, notice, this is an equation, one variable. We learned how to solve those already. I would subtract 2 on both sides. I get y equals 1. So that means when I plug 2 in for x back here, 1, I should get 1 for y. Now let's do it again. Let's pick another value. This time let's pick a y value. So we're going to pick a y value of 3. Let's just rewrite this. And now again we have an equation with one variable in it, x. So let's go try and solve for x. So we subtract 3 on both sides. We get x must be 0. So that means if you plug in 3 for y, x should be 0. Let's do it again. Let's pick some value for, let's say x is -1. So we do -1 plus y equals 3. Now let's add 1 to both sides to get that y by itself. So we get y equals 4. So if -1 goes in for x, 0 comes out for y. One more. If we plug in 0 for y, what do we get for x? Well, x plus 0 is just zeros. I mean, x plus 0 is just x, so we just get x is 3. So now you can go plot these because these are ordered pairs. This is 2, 1. This is 0, 3. It's -1, 4. This is 3, 0. And we can plot those points. So let's try 2, 1. That's here. 0, 3 is here. -1, 4 is here. And 3, 0 is here. And you can see they all lay on a, well, that's as straight as I can draw right now. Okay, so they all lie on a straight line. Okay, so why don't you try this one yourself? Here's an equation, and then it's going to ask you to pick these different values for x and y. Now, technically, you only need 2 points, because a straight line, you only need 2 points to draw a straight line. So you could just do 2, but this example they have you trying 3. Let me do the first one. So if we plug in 0 for x, using this equation, 0 for x, that's going to be 2 times 0 minus 3y equals 6. 2 times 0 is 0, so we get -3y equals 6. And now be very careful here, we don't add 3 to both sides, we divide both sides by -3. So we get y equals -2. So -2 here, so that's the order pair 0, -2, which is this point right here. Now what I'm saying is if you just had one more point, you could draw your straight line, but this example has you getting 2 additional points just to be safe. Okay, see if you can do that one on your own. And this one, same thing. I'm just going to get you started with the first one. Just with the first one here. Let's go with 7 for x. So y equals -2/7 times 7 minus 5. So I need to figure out what -2/7 times 7 is. And that's going to be -14/7, that's -2. So we get y equals -2, take away 5, so we get y equals -7. So we get -7 here. So I know on my graph, if I go to the right 7 and down 7, that's a point on my line. Now you have to go find the other 2, I'll let you do that yourself. Okay, now we have another one. This one is a really strange one, because the linear equation we have is y equals 3. There's no x there. So if you plug in 2 for x, what's y? Well, x has no impact here. There is no x in the equation. So that means y is 3. What if we plug in 0 for x? Well, again, it doesn't matter. Y is 3. What if we plug in -4 for x? Doesn't matter. Y is 3. So now let's just plot these points and see what we get. So 2, 3, go to the right 2, go up 3. Second one, don't move anywhere, go up 3. Next one, go to the left 4, go up 3. And here we go. We have what is called a horizontal line. So all horizontal lines will look something like this. It's y equals some number. That will be a horizontal line. Now what do you think you would have to have a vertical line? Well, how about this? Here it's saying, look, your x is always -5. So x is -5, there's no y in that equation. So that means I'm going to always be moving to the left 5, and then, let's see, down 6, left 5, down 6. And the next one, I'm going to go left 5, up 2. Sorry about Jumping all over the place there. Last one to the left, 5 up 7. And so all of your x coordinates are always -5. And so we have a vertical line. So all vertical lines will look like this. X equals a number. This is going to be a vertical line. So remember that. If you have x equals a number, you have a vertical line. If you have y equals a number, you have a horizontal line. And if you have x's and y's mixed together like this, you're going to have a line that either does that or that. It's going to have some sort of angle to it. It won't be straight up and down, it won't be left and right. Okay, I believe that is it for this section. Yes?